Okay. Hello everybody, it's Mr. Dolan here. I just wanted to talk to you today about a method we're going to use to compare and contrast information. So we've done a couple of labs now, and what we want to do is we want to compare our results to them to help us see the differences and the similarities between those results. It's just really focusing on that skill of can you see patterns and can you interpret what those patterns mean. So to do that, we're going to do what's called a Venn diagram. And a Venn diagram is just a way for you to graphically organize pieces of information and say, okay, which pieces of information are the same in both of these and which pieces of information are different. The first thing you need to do is you're actually going to record all the different properties of your thing. So today we're going to be looking at a equilateral triangle, and we're going to look at a rectangle. And we're going to say, okay, what properties do each of those have? And then we're going to compare and contrast those. Okay. And this is just going to be an example of how you're going to do this on the lab. So in an equilateral triangle, I want to list out all the different things that I can see about that equilateral triangle. So for example, I see that it has 3 sides. Okay. I see that it has angles. And if you know your geometry, we know that the angles are all the same. I can also say that the 3 sides are all the same length. Okay? So angles are all the same, the 3 sides are all the same length. And if you know your geometry, you also know that the angles for an equilateral triangle are 60 degrees. Okay, I know that the area, I can find the area of a triangle. Area equals 1/2 times, I'm going to actually just call it width times height. You might have learned base times height. It's the same thing. So we have that. Excuse me. And then let's see, what else do we know about this thing? We got sides, we have angles, we have area. They all have like a perimeter. Okay. They are considered a polygon. Okay. They're a shape. They enclose a space within themselves. Okay. So we could also say, oh, it's 2-dimensional. It's only got length and width. It doesn't, or height and width, it doesn't have depth, right? It is not 3-dimensional. Okay, so let's do the same thing for a rectangle. I'm going to kind of follow the same order that I did for the triangle, but I'm going to do it for the rectangle. So instead of having 3 sides, a rectangle has 4 sides, but they are not all the same. Okay, they have different lengths. In fact, parallel sides, meaning sides that line up, are equal length, but perpendicular sides are not equal. Again, perpendicular is like forming a right triangle, so where the 2 lines meet. Okay, so perpendicular are not equal, parallels are. Okay, a rectangle also has angles, and they are all the same angle, just like a triangle, except they're a different angle. They are 90-degree angles. Okay, you can find the area of a rectangle. It's length times width, times height. Okay, they have a perimeter, just like a rectangle does. They also are considered, I'm going to actually just do the polygon thing. I'm running out of space apparently. They are also a polygon, which again means it's an enclosed space. Enclose a space. Sorry, I'm not typing well. And again, this rectangle is 2-dimensional. It does not have depth. It's not 3D. Okay, so those are just some properties that we're listing out. Now in a Venn diagram, what you're doing is you're comparing and contrasting those. So what we do is we basically take our information and we lay it over the other one, okay? And what we're going to try to figure out is for the things that are rectangle properties, which of those properties are only for rectangles? And for the things that are triangle properties, which of those are only for the triangle? Okay, and then some things are properties of both. And so we're going to list out which of those are properties of both. Okay, so let's do that. I'm going to change my alignments here for things to make it a little easier to look at. I'm going to also change up the size, okay, and my margins. Oops, I'm going to do the whole thing, not just one. And make them a little bit smaller so they don't run into the other spaces. Okay. So things that are both true for rectangles and for equilateral triangles. Now let's look at this. Which things can we say are true for both of them? Well, I'll use a list. They both have sides. Okay? We don't know what's important, what's not important, but let's just say we know they both have sides. Okay, we know, shrink this up again, just like we did with the other ones. Okay, so they both have sides. Their angles are all equal, meaning the triangle's angles are all the same and the rectangle's angles are all the same. But if you compare the angles of a triangle to the angle of a rectangle, they are different. So that'll be something we put differently. They both they have an area. Okay. We can measure their perimeter. Okay. They are both considered polygons. Okay, and they're two-dimensional. Okay, so now let's look at which of these things are true for only triangles. Well, a triangle has 3 sides, where a rectangle has 4 sides. Okay. In a rectangle, the sides have different lengths. Okay, I'll get rid of this stuff because I think we understand what that means. In a rectangle, the angles are 90 degrees. So I'm going to put this here. Sides are all same length. In a triangle, the angles are 60 degrees. Okay. In a triangle, the equation for area and the equation for area in a rectangle are different, but they both have an area. Okay. They're both considered polygons, so that I'm going to take out of there. Okay. I'm going to put back here. The rectangle has a perimeter. Okay. So this is what we would call a Venn diagram. The areas here are things that are only for triangles. The areas here are things that are only for rectangles. And then this middle space here is kind of where those 2 rectangles of information, those properties, they overlap. And that's what's telling you how they are similar to each other. And I want you to use this idea and I want you to think about how we could apply this to our labs. And on the next slides on the presentation that you're watching, it will have information specific for the lab that I'm asking you to do this on. But I'd like you to use the same idea. So 2 rectangles that are overlapping and compare and contrast those. So what things are similar, that would be like the both area in the middle here, and then what things are true only for one versus the other experiment. Okay, if you have any questions, again, please email me and I will try to get those answered as quickly as possible. Thanks. I hope you're all doing good. Take care.